Hey guys, this video is a combination of two sections worth of graphing. It's sections 4.2 and 4.4. It's exponential and logarithmic equations and graphing them. And the deal is these two are inverse to each other, so they really make more sense together than as a separate topic. So I'm going to start with actually just doing a problem, and then I'll come back to kind of this summary sheet and kind of show how all this fits in with an actual picture and example. So this is an exponential. And exponentials, remember, take the form y equal b to the x, some base to the x. And to graph these, probably the easiest way is just to make a table. The good numbers are going to be -1, 0, and 1. I'll start with, I'm going to go backwards. 5 to the 1. Hi, Misha. Sorry, my cat's interrupting here. 5 to the 1 is going to be 5. 5 to the 0, remember anything to the 0 equals 1. And then 5 to the -1, remember that that's the same thing as 1 over 5, so to the first. So negative exponent, we drop it downstairs. So this is going to be 1/5. And then if I graph these, that's going to give me what a basic exponential looks like. So when x is -1, y is about 1/5. When x is 0, y is 1. And when x is 1, y is 5. And we get a curve that kind of looks like this. And then this side, Misha. All right, here's Misha. There's Misha. Okay, so then this side, without a cat, should just kind of trail in towards the x-axis, but never actually touch it. And then this side's going to grow really fast. You can kind of see the reason I didn't use -2 is because that would have come up to 1/25, which isn't really meaningful in my little tiny graph. And I didn't use +2 because that would have been 25, which is way, way up here and way off my graph. So that's why -1, 0, 1 are going to kind of be our good numbers to use. Our domain for all exponentials is -infinity to infinity. Our range, our basic one, if there's no up or down shift on them, is going to be from 0, not inclusive, because we're only going to get closer. You can see I'll be at -3, 1 over 125. It'll just keep getting closer to 0, but never get there. So 0 not inclusive to infinity. And then we get what's called a horizontal asymptote. And so that is a value that the function approaches as it either goes to infinity or -infinity. And so in this case, we have a horizontal asymptote right there. It's the x-axis. And that line, remember, is y equals 0. When we have y equals a number, then that just means we have a horizontal line through that value. So horizontal is y equals 0. And so that's your basic exponential. So coming back here, what we just saw was, here's our form. B can't be 0 because that's not meaningful, and if b was 1, it would just stay 1 the whole time, so also not very exciting. We're always going to have this horizontal asymptote of y equals 0, other than when we get up and down shifts. Domain, always -infinity to infinity, and the range is going to follow the asymptote with those up-down shifts here in a second. So then let's do a logarithm. And log functions, in theory you've seen these. So the deal with these is they are the inverse of an exponential. And so if I were going to say find the inverse of this, the first thing you would do is write y equals, sorry, you wouldn't write that. You would write x equals 5 to the y. And so this and this mean the same exact thing. And so the way these work, you might remember, is if I have a log base 5 of x equals y, that's the same thing as having 5 raised to the y equals the x, or 5 raised to the y equals x. And so that's the exact same thing I have here, just written in the other order. So exponentials and logs, inverse functions of one another. So in terms of the table, I can either just set up a table with -1, 0, 1 for the y's and plug into this. So that would be 1/5, and then to the 0 makes 1 again, and to the 1 makes 5 again. Or I could think of this table and just flipping it. So if logs are a little bit rusty for you, you could jump forward and watch the beginning part of the 4.3 video for this course, and that would give you a little refresher on just sort of the basics of logs and switching from what's called log form to exponential form. So once we have this, now we can graph it. The 1/5 -1 is sort of the hard one to graph, so I usually start with 1, 0. I'll go 5, 1. And then the 1/5 -1, 1/5 would be just past the 0, and then down at -1. And so what we're getting is sort of the inverse graph, not sort of, very much the inverse graph to this one we got up here. The domain on this is going to be 0 to infinity, and if you look, that was the range on this one. This one's domain was -infinity to infinity, so that should be this one's range, which if we look at the graph, it's going down forever. It's slow, but it's going to go up forever, so it is this. And then this one has a vertical asymptote instead of a horizontal, and it's going to be right there on the y-axis. Remember, for vertical lines, those take the form x equals 0. So the asymptotes are going to be a little backwards from what you would think. Horizontal lines, just recall, are y equals 0. Vertical lines are of the form x equals 0. And so then going back to the sheet, just to kind of summarize, when we have a log of this form, we can write it in the form, again, b to the y equals x, or b to f of x, if we think of this as y, base to the answer makes the stuff inside. Has the same restrictions on b as the exponential. This time we have a vertical asymptote instead of a horizontal, and then our domains and range are the same except backwards each other because they are inverse functions. So what we had back here was is basically an example of a couple of parent functions. And what will happen as we do these is the base can change. This could be, for instance, say this was y equals 3 to the x. I get a very similar table if I put in -1, 0, 1. I just get 1/3, 1, and 3. So it would be a little bit higher here through 1 and a little bit shorter on that side, so just not quite as steep a curve with a smaller base. So for all of these problems, we're going to kind of start with this and make a parent function, because this doesn't have a set one like x squared, because that base can vary. So it's the same basic thing, but it's going to be 1 over the base, 1 in the base is pretty much how these go every time. But we do have to make that kind of new shape each time we do one of these. For the examples I'm going to keep sticking to y equals 5 to the x, just so I don't have to make a new parent function every time. So I'll be referencing these two for the next several examples. So if you look at the notes I have in there, kind of all the same shifts that we saw back in 1.5 transformations, except we're not doing the stretches and shrinks in this section. So we're sticking to vertical shifts. Remember, that's where you add or subtract kind of outside the function. Horizontal shifts, that's where you add or subtract inside the function. And then reflections, and that's the negatives, either inside or outside. So let me show you what that would look like with some of the exponentials and the logs. So for number 3, we got a couple of examples here. So we have this one. I'm going to do the parent function in light blue, I think. So I'm just going to keep drawing this thing over and over. And then, let's see, I bet that doesn't stand out. Let me try this. We're going to go green on this one. Yeah, I think that'll stand out pretty good. So for this one, we're going to have, so for this one, we got y equals 5 to the x, and then a +3 tacked on the n. So what that's going to do is take this parent function and just take all these points and move them up 3 units. So 1, 2, 3, and 1, 2, 3. So the fraction one's a little bit hard to count the boxes. That tends to be where people make an error. So if you remember, we had, for the blue one, we had a horizontal asymptote right here at 0. If this shifts up 3, then we're going to have a horizontal asymptote at y equals 3. And so like on an exam, I'd ask you to identify that, so I'd be looking for you to draw it too. But if you draw that in first, what it does is it just kind of gives you a reference line so that your graph ends up kind of where it should. And with this, we don't want to draw it going past that asymptote because, our range on this would be from 3 to infinity, so we can't show it, dipping down here. For B, this one has a -2. but it's on the inside, so that's going to be right 2. So I just take the blue one and move all my points right 2. And then that would be my transformed graph. Let's see, for these we got the, and then I changed it up to some 3's here. So I guess I'll show how to do that one more time. Y equals 3 to the x. So xy, so we'll just do -1, 0, 1, and we get 1/3, 1, and 3. So there again is how to make a parent function. So I'll just do that one in dark blue. So that would look kind of like that. And then let's see, this first one, so I'll do this one in green, that's got the negative on the inside, and so that's going to reflect across y, or it's going to mess with the x values, because when we mess around on the inside of the function, that messes with x values. So this is going to be over here, and then this side will be down there. So look just like that. And then the negative in front, that's the one where it messes with the y values. So that's just going to take this blue graph and reflect it across x. So we'll get something that looks like that. And then here's same basic idea, but with the logs. So I'm going to copy over that. Well, I'll go ahead and do it one more time because everyone has a hard time with the logs. So this would be y equals 5 to the, the basic version would be y equals log base 5 of x, as that means 5 raised to the y equals x, xy. So I put my values in for y just because it's easier, and then I get out my values for x. You can also just, you don't have to write all this stuff, you can just skip right down to here, or you can just think of it as 5 to the x equals y and then reverse the table. So a couple of different ways to get there. So this one again was right here, here, and here. So that would be my parent function. And then, let's see, for A, we have a +2 on the inside. So that's going to move my graph left 2. This one has a vertical asymptote at 0, so I'm going to go ahead and draw that in, because it's also going to move left 2. And so I can just pick up all these points and move them left 2, and then that's about it. So my new vertical is at x equals -2. And for this one, it has a +4, so that's going to take the blue one and move everything up 4. And for that, the vertical and everything stays the same. These ones, so again, let me draw the parent function in just for reference. So that's right here, here, and here. So negative on the inside messes with x values, so that's going to fold it across the y-axis. And then negative on the outside, that's going to fold it across the x-axis or mess with the y values. Get that one right there. So for number 7, this is kind of a special one. I think there's somewhere on the homework where it asks you to identify these. They are hard to graph because they come up to kind of crummy decimals, but they're functions we use a lot, so just kind of showing a graph of them. So E is approximately 2.718. You should see this button on your calculator. If you find the natural log button and then look for the second function of this, it's going to be E. And so we would just do a table like we would. And if you put in the same -1, 0, 1, I think e to the -1 is like, I think it's like 3.37 something something or 0.36 something something. So I'm just going to call that about 0.4 because we're just graphing on a little tiny graph. E to the 0 would be 1 because everything to the 0 is 1. And then e to the 1 would just be about 2.7. And ln is its inverse, and so it's that this is basically the same thing as y equals log base e of x, and so this is e to the y equals x. So that means it's just going to be the inverse table of this one. So 0.4 gets me -1, 1 gets me 0, and 2.7 gets me 1. So like I said, not great ones for graphing, but pretty important, really important exponential and logarithmic functions actually. So to graph this one, it's an exponential, so when x is 0, y is 1. When x is 1, it's about 2.7. -1, it's about 0.4. So I get something that looks kind of like that. And then for the log, I got 1, 0, and then 2.71, and about 0.4, -1. And so that looks like that. And there you can see that, that inverse, where if I folded it over the dashed line, these again would sit right on top of one another. Okay, so the rest of the examples are pretty much like what you would see on the graphing supplement for this section. Again, I don't think on the computer you get adequate practice graphing, and the fact that the computer kind of draws it for you means you don't have to quite know what you're doing and you can still get them right. So the supplement is meant to prepare you for the test. Anytime I do a graphing supplement, you're guaranteed something off of it is on the exam. So these are all just kind of multi-transformations with exponentials and logs, just kind of more than one transformation happening at a time, same as we saw in 1.5. So I would start with this. I would think of it as y equals 3 to the x, and I can make my little table, -1, 0, 1, and that'll be 1/3, 1, and 3. And I'll just throw my parent function down. And if you can see this in your head, that's cool. You don't have to draw this. Most people are going to have a hard time kind of making these in their head. So I think for me, I like to draw the parent function, and then I can just use that to copy over the rest of my stuff. So I got a -4 on the inside, so that's going to go right. And I have a +3, so that's going to go up. So once I kind of figure out the up, then I can draw in my new horizontal asymptote. So it's going to go right here. And then I can just take each of these points and move them right 4 and up 3. And I kind of start with any one other than the hard one, so I'll start right here. Right 4 and up 3. This would go right 4 and up, right 4, up 3. And then this one I can just kind of copy it from the shape. It should be right about there. And so that'd be my transformed graph. With this, now I have domain, -infinity to infinity. Range would be from 3 to infinity. And my horizontal asymptote would be y equals 3. And so that's kind of how you would see this on the exam with these questions and asking you to draw something like that. So for this one, we got y to the 4th, y equals 4 to the x. So xy, so it's going to go -1, 0, 1, 1/4, 1, and 4. So same basic shape. Hopefully that's getting really comfortable. And it'll look about like that. So then, to do the transformation on it, just look and see what we got over here. We're going down 3, and then this is going to be, there's a negative on there, so that's going to be our reflect across the y-axis. Reflect y. So I think I will do the reflect first and then move it down. So I'm going to go reflect across y would look like this. And then I need that to move down 3 units. So do here. And so this is moving down. I'm going to go ahead and draw my horizontal asymptote in. So we can go ahead and say, hey, that's going to be y equals negative 3. And then I just move everything down 3. So here, here, oops, someone's at the door, and here. Okay, so then we got our domain is going to be all real. So negative infinity to infinity. And our range is going to go from that negative 3 up to infinity. Okay, so this one's going to be y equals 5 to the x. And that's that one I did earlier, so I'll just go ahead and draw it. And kind of once you can do this too, you just think of it as 1/5, 1, and 5. There's no reason to make the table. It's just to kind of get you going. And then what do we got for transformations? We do have a reflection. So I'm going to do that first because I think it's hard to both go, we're going to have to go 3 to the left, down 2, and then we're going to reflect across reflect across x. Reflect x. So I'm going to do the reflect x first just because I think it's easier to shift everything once I have the reflection done. So it's here and here. And then from there, I'll just take the green one and then do what this says. So I'm going to go left 3 and down 2. So I'll set up my new, since we're going to shift down 2, that means my horizontal asymptote will also shift down 2. So bring everything down 2 and left 3. So down 2 and left 1, 2, 3. Down 2 and left 1, 2, 3. And then this one I just always kind of look at the picture and go about there, because it's hard to count with the fraction. And then that would be your new graph. So our domain, all real again, as it is for all exponentials. Our range this time is going from negative infinity up to the negative 2, not including. And our horizontal is y equals negative 2. Number 11, we shift to logs. And so I did the exponential form here just to kind of help people get going. So we're going to plug in for y's. And that's just that base 6 is our base, and our x and y are swapping places, is how I'm getting that. So this would be 1/6, 1, and 6. So I'll stick with magenta, I guess, since I started in that. So we'll go 1, and then 6, 1, and about 1/6, negative 1. And so this one is going to be, it's going to be reflected across the y-axis. Change colors. So reflect y, and then up 4. So let me draw the reflection, and then I'll move everything up 4. So there's just the reflected part. I got that a little bit high, but should have gone through right there. And then bringing everything up 4 will be right here, and about there. And I did it again where I got that a little bit high, but oh well, you know what I'm shooting for. So domain is going to go negative infinity up to 0. And the range on this one, that's our all real. Because remember, inverse to this. And then our vertical asymptote didn't move because we didn't have a left or right. So that's just going to be x equals 0. Okay, so for this one, again, I just threw this over here to help if you haven't done logs for a bit. This piece might be a little bit tricky for you. Hopefully after we get through 4.3, how I'm getting this from this won't be too mysterious. So negative 1, 0, 1, so it'll be 1/4, 1, and 4. So here's our parent function. And then no reflection, so I'll just go straight to what it is. This would be down 3 and left 4. So like I said, that it's going left 4 means that I'm just going to do the vertical asymptote. So we'll just say that's going to be x equals negative 4. And then I move everything left 4 and down 3. So 1, 2, 3, 4, and down 3. 1, 2, 3, 4, down 3. And then this one should be kind of just right up against the asymptote. So there's our transformed graph. Domain is going to go from negative 4 to infinity. And the range is going to go from negative infinity to infinity. And last one. So this one is base 3, so it'd be yx negative 1, 0, 1, 1/3, 1, and 3. Oops, that should be there. Sorry about that. 1, 0, and right there. So ignore that one. And this one has a reflection on it right here. So that's going to reflect across x. Reflect x. So I'm going to draw that first. And then I'll go ahead and do the rest of it as a separate step. So this is going to go up 4 and right 2. And so since we're going right 2, I'm going to go ahead and draw my vertical in there. Oops, wrong color. And then I'll just take the green one and move everything up 4 and right 2. So I'll start with the easy point, right 2 and then up 4 would be there. This one, right 2 and up 4 would be there. So then this one is a little bit before the other, so I'll put right there. And there's my transform graph. And so my domain is going to go from 2 to infinity. My range is going to be all real. And my vertical is going to be x equals 2. And that concludes graphing with exponentials and logs.